So you have made it to the 2025 lecture series. This is, I think, the, let's see, one, two, three, fourth of our six-part series about consultants' role in architecture. My name is Brian Stryzik. I'm an architect at Kennelly Architecture and Planning. I was also the AIA East Bay board president in 2022. So since stepping down as the board, being on the board, I've been working on this lecture series. This is the third year we've done it. We've had over 50 participants in the first 2 years and a lot more this year. So it's been really exciting to hear people talking about design, architecture, their roles, challenges, and based in East Bay projects. So it's been really inspiring to be part of this. So tonight, our lecture series is about consultants. So consultants are such a critical team member in all projects and really helps make projects successful. And structural engineering is a sometimes hidden key element, but a very big part of building. So I'm glad we're going to be able to gather and talk about that. So we're going to do short presentations by each of the presenters tonight. And then lead into a moderated discussion. But if you have questions, please don't hesitate to talk to us. So tonight we have 4 principals, 2 Marks, 2 architects, and 2 structural engineers. So pretty exciting. All these people are very well educated and very informed about the topic. So excited to see where the conversations go. They all also have very distinctive presentations about what they want to talk about. So that's exciting too. So when we get into the presentation, we're going to start with Mark Sear. Oh, I'm going to mess it. Steyer. He's a principal at Tipping. And then we're going to go to Winston Wynn, who's a principal at Phillips Wynn Architecture. Then Mark Donahue, who's a design principal at Lowney Architecture, and end with Anthony Dente, principal at Verdant Structural Engineering. So, so before we get into presentations, I have a quote I want to read and see what you guys think about it. So this is a quote from O'Vera. We've been doing architect quotes, but this time structural engineering quotes. So we'll see what you guys think. Engineering problems are underdefined. There are many solutions, good, bad, and indifferent. The art is to arrive at a good solution. This is a creative activity involving imagination, intuition, and deliberate choice. Any thoughts on that one?
One of the things that was going through my mind, one word, which I agree with all of that quote, but one word that I would have added to it is collaboration. So it's really a team effort, and the idea of saying that there's no right or wrong answer and that there's a lot of imagination to come up with the right one really takes good communication, listening, teamwork, and kind of exploration together with the whole design team. That's what we find in our practice. So that came up for me.
Well, I think an observation about this panel in general is I definitely think structural engineers are undercredited when it comes to creativity. It has been one of the signal delights of my career working with very talented structural engineers and just arriving at those aha moments together. It's truly remarkable. And after all this time, you failed to mention the mileage, the pleasure of that, but also the intrinsic intuitive knowledge that's been conveyed to me about how things actually stand up, I deeply appreciate. So
I can say something just about creativity too. I'm constantly looking at a complex lateral earthquake resisting system and to a new employee or younger engineer and said, this is really the creative part. And then I stop myself. I feel like I have to step back and say, well, like in an engineering. But it comes out of my mouth so honestly, and I really embody that and enjoy that part. It's very real.
Yeah, I feel like that quote, you could generalize it to any building project and architecture as well. Speaking for kind of my experience working with structural engineers, it's really that collaboration and that ability to quickly and collaboratively problem solve. That's been so critical for our projects. We do a fair amount of renovation, where it's tricky to find a solution that will work with existing conditions, that will fit into the budget and not interfere with other plans that you may have for what you want to do in the renovation. So it's been really critical to have that collaborator on the team.
It's interesting, both two people mentioned collaboration. So what makes this successful? Is like, how do you choose your engineers? How do you have a really successful project between the architect, engineer, and the rest of the team?
Well, I'll say that we've had the pleasure of working with some really great engineers, repeat on, several projects. And, this is the first time we've had the opportunity to work together. We're currently working on a project together.
And so next to each other and still communicate stuff.
Yeah.
Miles.
Yeah.
We were actually at a site visit today trying to creatively problem solve while getting introduced to a problem that was just revealed when they cut back the drywall. So, definitely in the moment, both taking in information and being able to offer solutions and next steps. It's an art.
Interesting, the question of how do we select? Obviously, people you've worked with in the past, or colleagues of people you worked with in the past, there is a certain ethos that emerges. For instance, tipping, one of our favorites. We're still trying to find that project to work on, but having worked with tipping in the past with Leo, there's a spirit of creativity that for us is essential. And those are the structural engineers we really enjoy working with, is the ones who approach it with an open mind. And that fits in with the way that we also approach projects. That's where the joy in building really lies.
I love that you guys brought up creativity again, which is good, because I think engineering, it's not maybe the first thing that comes into our mind. So I'm glad that you rolled that back into that. It's critical to making successful partnerships.
As an engineer, I know that our clients have a lot of choices, and as Warren Buffett talks about business, it's a web of trust, right? And so our job in this industry, because these problems are complicated and you don't know the answer right away, is to somehow be able to communicate and convey to our clients that they can trust us to go through that process, which can have lots of challenges, and end up somewhere where they're going to be satisfied and fulfilled with the result of our collaboration. And so, that's a very important part. I know as architects, you probably feel the same thing with your clients. They don't know exactly where they're going to land when they have the concept of a project. So this whole enterprise that we work on together is really built on being able to communicate, being able to explain what you're trying to do, and then delivering and being able to be sensitive throughout the process to kind of building trust. And as Mark said, it's really about, hopefully establishing long-term relationships that allow you do bigger and better things.
Those relationships, sorry. Go. And those relationships are with architects, but you're also sometimes probably hired by owners and clients, right? Directly. You're still, is it different the way you interact with owner, if you're hired by the owner versus by the architect?
Well, this is a service business, so we're always mindful of who our client is. But I think, to be successful, there's really some basic commonalities that are going to apply in any design situation. And really, again, that comes back to understanding what your client's goals are and understanding how you can give them good information and how you can work together and being good listeners. So, there's times where we work directly with the client. If we're doing seismic renovations, oftentimes we're brought in much earlier than on a maybe new building of a traditional type. And we're brought in as they're assessing whether or not a seismic renovation is going to kill a project or whether it's feasible. And so, our job is to kind of explain possibilities and kind of describe options and educate, not just kind of go away and come back and give an answer.
Yeah, I'm at like a result of trust that relates to like like a lot of different clients is like really feeling and knowing the why behind every decision. And I find that it's when you understand that why, like how much emotion is involved in the why behind this choice versus how much practicality or cost budget consciousness, like something might look funny, but knowing why it looks funny, this would be my first choice. And it happens quite regularly, it's not my design, but, and that's really getting to the core. That's what helps us jump. You're going to working with a lot of product developers now, in the kind of alternative or low carbon building space. And they've got different drivers, and some of that's also coming from possibly funny places like their funding source or whatnot. When you really know that, then you can be versatile in offering the best solution for the case that they might not be aware of, but that's why they hired you.
That's great. I think that's a good start. Keep on going, I think, but let's just conversation, see how those collaborations have turned into questions.
All right. Great. So yeah, I'll just talk a little bit just to kind of share a little bit about tipping. So tipping, we're structural engineers. We're about our 42nd year of business, and we're located here in downtown Berkeley. We have 2 buildings just a few blocks away. And over the years, our client base has expanded. We've grown kind of steadily over the last 40 years, and we're about 40 engineers now. So it's been a slow and steady growth. And as you can see on this slide, we have a wide range of clients: public entities, private developers, nonprofit developers, artists. So we do a wide range of projects, and we've focused on seismic retrofitting, innovative structural systems, and performance-based design. And so, we're always looking for innovation and trying to push forward the craft of structural engineering. So that's a photo of our office. So please come by and visit us anytime you're here in downtown Berkeley. We're trying to blend, rigorous thinking grounded in physics and engineering with a service mindset. I've talked about kind of understanding our clients and collaboration, blending that with our technical experience to provide value on our projects.
Who's the architect of your building?
Local architect Richard Furneaux and Laura Hartman. So our firm was founded by Steve Tipping in 1983, started in his basement. And, Steve's approach to engineering, which he's passed on to all of us, is trying to kind of maybe invert what some of the classic approach to engineering is. And that's really, not to say that all engineers are like this, but sometimes there's a tendency to think about engineers as wanting to go away and kind of come up with the answer and hand it to you. And that's really not the ethos that we're brought up in. So while you might think of engineers as accepting givens, performing calculations and creating details and drawings based on that, we're really trying to invert the process and understand project goals, integrate the structural design with the architecture, kind of push forward the design before getting deep into the calculations. Of course, we have to kind of have an understanding of where we think it's going to go, but not getting lost in calculations, because that's not really what's valuable to our clients. And so kind of creating details and providing verifying calculations at the end. So we're trying to solve the project's problems, not our own problems. We're not trying to make it easy as engineers, and we're trying to take a whole project perspective to have an integrated design. And really what this requires sometimes is taking risks and being uncomfortable. Sometimes we have to do things differently than we've done. We don't have the last job that's exactly like this one. We have to ask our clients to trust us that we're going to get there, even if we're 80% sure that we're going to get there. And we're not sure how we're going to get there, but we know we're going to get there in the end. So it does require a little bit of uncomfortability and risk taking. And I'm just going to browse through a couple projects more just to show the range of projects that we do. So we do artwork and landscape parks. This is at Yerba Buena Island with Walter Hood's office, a great local landscape architect. This is at the Cal Academy of Sciences, so a jewel boxy glass and steel structure that my colleague Ian here in the crowd designed several years ago. Public design build projects, moderate scale. This was a recent project in Contra Costa County, converting what would have been a steel building into a concrete building and doing a kind of quick design build delivery. This was a seismic retrofit in Southern California where you can kind of see it in the right-hand side. The previous engineer scheme was a pretty traditional scheme that was going to cost $14 million. And we used performance-based design thinking, and deep understanding of the existing structure to basically harvest the strength of what was there and meet the requirements of the seismic retrofit for $3 million instead of 14. So this is about, understanding existing buildings and what strength they have and what their behavior is going to be. So we're not over designing in the case that there's only a certain requirement for a seismic retrofit. And then this is another retrofit for UCSF. This is a building that was donated. Once again, UCSF was not going to take this building if it cost too much to retrofit, or they didn't think it would be worth it. The original retrofit was going to be about $20 million, and we came up with this exoskeleton scheme that allowed us, because it's UCSF and not San Francisco, to get through planning quite quickly, integrate some sun shading on what was a pretty flat south-facing facade, and do a lot of work from the outside so as not to disturb the interior finishes, which had actually recently been redone when it was a private building. So this was a conversion that went from $20 million to $4 or $5 million. And again, this provides real value, and hearing where the costs were, we came up with alternate solutions. And this is a new project just up the street at UC Berkeley that we're working on right now. So again, getting the range of scale of projects. This is a new high-rise residential project with an architect out of Philadelphia that we're just about completing construction documents on and excited to see move forward. So that's a bit about tipping. I'll pass it on to Winston.
Sure, go for it.
The Philadelphia architect in the California ones.
Yes.
Okay. Good evening, everyone. I'm Winston Wynn, principal of Phillips Wynn Architecture. I'd like to just start by kind of grounding that our work is really driven by a social agenda. Many of our clients are nonprofit organizations serving the community. So what we aim to do with every project is to instill it with warmth, with energy, and a common desire to recognize a common human spirit. As I mentioned, our work for nonprofits focuses on two kinds of mission-driven organizations, ones that provide housing to the community, and others that provide more like the community services side. So I brought a couple examples of each of those types. So first, starting with an older project, this is Girls Inc. of Alameda County, downtown Oakland. We took a building that was originally constructed in 1919. That's the middle image, as the headquarters for the East Bay Water Company. So this is where back in the day you would go pay your water bill. It had gone through a series of renovations over the decades. Our clients found it in 2010 and found that many of those previous renovations were not very sympathetic to the original building. The building also required seismic retrofit for the change of use. That retrofit included a steel brace frame in the rear of the building and a concrete shotcrete wall in the front of the building. These are just a few of the images of the finished spaces where you can see some of those elements really highlighted and integrated into the finished spaces. And then jumping ahead to a more current project, we recently completed a Rise Commons in Richmond. This was a project where we renovated an existing building, added a new 12,000 square foot pre-engineered metal building, and created a little campus for this youth organization. The construction had just started when March 2020 occurred. So these images are both kind of a snapshot of that moment, as well as showing kind of the two systems in that new building. There's the pre-engineered metal building, and then we learned along the way that we couldn't directly integrate an elevator like we had planned with that system. So we actually have a building within the building to house the elevator. And these are some images of the finished spaces. The images on the right are the new building. Bottom left is the renovation of the existing building, and top left is the courtyard space that kind of ties the whole campus together. Moving over to our affordable housing side, again, starting with an older project, Jefferson Oaks, downtown Oakland. We took two historic, older, not necessarily historic, but older hotels. And we renovated both of them, joined them at the lobby level to create a single affordable housing facility. One of the challenges of this project was that we had to maintain either some of the businesses in continuous operation, the ground floor businesses, throughout the whole project. So the corner space actually never closed. And then the spaces up the street towards the state building, only for a minimal downtime. So that meant any new seismic elements that we brought into the building could only occur in certain spots in the building. And of course, that meant that we had new brace frames going right through our lobby, right through our main entrance. But we figured it out. These are some images showing the steel pick and that steel getting slotted into the building. And in the next slide, images of the finished spaces with those elements in place. And then I'll end here on a more recent housing renovation. This is our Beth Asher project for Saha in the Diamond District of Oakland. And this is actually the sixth and latest building of a series of buildings we renovated for Saha, Satellite Affordable Housing Associates. And they're all 1960s concrete frame, senior housing, affordable housing buildings. They all had seismic deficiencies. They all, this is pre-ADA, all had accessibility issues. They all suffered from horrible entrances and, like community spaces that were afterthoughts. This is the era of build a lot of housing, but not necessarily always the highest quality housing. And what we were able to do was the series of images on the main image and at the bottom is create a whole new entrance sequence for this building, starting with a new ramp that replaced a very steep and very narrow ramp that was there before. A new lobby in a new spot that connected to services and management offices and a community room beyond. That was a really logical layout that was light, bright, warm, and welcoming, as opposed to the existing condition, which was the image on the far right in the middle, where you came into this little lobby that was really dark with these horrible fluorescent lights, and you had no sense of like where to go from that space because all of the spaces I mentioned were just solid doors down the hallway. So we're really proud of the work we were able to do in concert with some of the structural work that occurred here. The image at the kind of top middle, that's our Satellite Central project. Some of you may know in the uptown area of Oakland. That was one of the first of that series of 6 buildings. Oops. And then this last slide, just to highlight the seismic retrofit for this project. It included both a concrete shear wall that we exposed and applied to the outside of the building of the rear wing and becomes a feature in the rear courtyard. That's really lovely space with these old redwoods right on the creek, as well as elements that are more invisible in the final work. So in each of these 6 buildings, the engineers came up with a strategy of doing a fiber wrap on the existing concrete stair and elevator cores. So after the fiber mat reinforcing was applied, the finishes were restored. So you don't even see that portion of the retrofit in the finish work. That is my last slide. That's cheap.
Anyone has any questions about either one of those presentations, please? Yeah, you want?
That one was IDA Structural Engineers in Oakland.
The question was who the structural engineer was for that project.
Okay, so this presentation usually takes about 45 minutes, but I'm going to, first of all, do some Evelyn speed reading, but also cut down on the overall scope. The basic idea here, we do a lot of prefabricated, and it's a fascination for me as an architect. It's sort of the old dog learns a new trick, but also from a structural standpoint, it presents a lot of very interesting and innovative challenges. Also part of the theme of innovation in construction technologies. So without further ado, of course, we all know that this stuff never takes place in a vacuum. There's always a team of people involved. This is our team over at Lowney. We have offices in Los Angeles, in the beautiful Bradbury building, in downtown Honolulu, in Chinatown, and also in downtown Oakland, where the firm was founded about 23 years ago. What we do, we kind of cover a broad band. Our primary practice right now between residential and hospitality, that's about 60% of our work. But we also do adaptive reuse, probably not to the same scale as Winston. And we do master planning, but we kind of grew up doing grocery stores. For instance, we did the Whole Foods there at Lake Merritt. And that actually was an inroad towards the prefabrication world. We've done 25 projects using prefabricated technology, one panelized, and the balance of them volumetric modular. And as I say, very fascinating to me, all the projects pictured here on the right are modular buildings. And so part of what we like to do is confound the expectation that a modular building is a box. So what we have done recently, and this is really focused on our multifamily work, is to start off with the premise that every single project, whether requested or not, is modular. And I'll explain why that's important in a moment. And what kinds of buildings can you do using prefabrication? We can do any building using prefabrication. I think we've seen some great examples lately. For instance, Oh Wow has that high-rise tower in downtown Oakland. That's prefabricated of a different type. That's all cross-laminate. No, that's mass plywood. But we are primarily focused on volumetric, which means you build it in a factory and you ship it out to the site. That has huge advantages. We're doing a medical office building right now. We are doing 5 projects that are residential multifamily, all volumetric modular. And this is why. Cost is just a huge impediment right now for any development. What this allows you to do is save on time, and time is money. And the way that works is that normally what you have to do is you do the foundation, you build the podium, whatever is required to set the stage. And then the carpenters come in and frame it up. And then the finishers come in and fill it out. What prefabrication allows you to do is while the site work is being done, foundations, the plumbing, the connections, utility connections, there's a factory somewhere that's actually building the superstructure. And you'll see some examples of it in a moment. But as you can imagine, if you're doing those as parallel track processes, you're going to save a lot of time. And it's actually pretty remarkable to see a building appear out of nowhere in the space of a month, which is how most of these go down. It does require that you have some discipline about making decisions. And that is why it's so important to have the team on board early on, because there's 2 stages to this. I'll talk about that in a minute, that there's not only the integrity of the box itself, but then there's the usual concerns of shear and seismic lateral. that come into play. There are several different types of prefabrication. We've done the panelized systems, and we've done volumetric. Shipping containers was kind of a flash in the pan until people realized that you cannot live in a space that's 7 foot 6 inches across. We have done projects here in Berkeley that use shipping container technology, but that are actually built custom. So it's strange hybrid. This is back when you could still get things from China without a 25% tariff on them. And then 3D printing technology, generally, we don't do that. We are starting to entertain it, but it's really geared towards single or two-story, and that's a very small percentage of our practice. So here we go. There's two types here that we've work with commonly. You've got wood, both type 5 and type 3. For those of you who are unfamiliar with those, that's just the code designations for the fire resistance. And then steel, which is in some cases type 1, sometimes type 2. But we've done both of those. And this really gives a preview to what's in store. One of the things it does is it imposes a certain rigor on the planning of the units. You can see here in this illustration that we've got a studio, a 1-bedroom, and a 2-bedroom. Each of those is divided into a box that can be built in a factory. And then we stack them together on the site, and there's a little bit of stitching that goes on. We do the exterior of the building on the site. But ideally what you're doing is you have rooms across the hall from one another, and the corridor, that entire segment, that slice of the pie, is built in the factory. And so if you can pull that off, you're looking at this plan, you're probably going, well, that is just a dumb rectangular box. However, it is possible to dress them up in a way that you don't recognize. The floor plan that you just saw is exactly this building. And so it is possible to get away with that, just in case you're interested. So this image is a project in El Cerrito. This is Mayfair near the BART station, El Cerrito del Norte. And I think this really illustrates several of the principles. One is you have a box that you're lifting 90 feet in the air. That thing has got to be self-supporting from day one. It has 6 sides, there's a floor, there's a ceiling, there's 4 walls. It has to be stiff enough to be picked up without wrecking all of the interior finishes, without everything capsizing, because this thing is shipping with the appliances, cabinets, the finishes, the drywall, everything is already in the box. And that is the key to the speed of it. However, when you pick up 20 to 40,000 pound object, there is the opportunity for it to flex. I mean, this picking system is really great because it has 8 points, but we have had that experience where it does flex and you do have to do a little bit of patching. Totally essential to have an engineer that understands that. Now, we typically have an engineer that does both the modular portion of it and the site portion. It's natural, but we have separated them before, where you have somebody who's doing the box and then somebody who does the overall building. And then the other aspect of it here, this is where the innards of the building are exposed. The left-hand image is the connection to the foundation. So the first thing is that you really just have a loose stack of boxes sitting out there in the field. You've got to connect them together. And we really rely on our structural engineers to nail that down, so to speak. So we have these strap connections between boxes. We have strap connections between floors, and that's taking all of the loading during a seismic event to keep everything glued together. And you can see that it's light gauge metal plus sometimes a more robust bolted connection. And then just like any building, we have to deal with issues of shear and lateral. And you look at this building, and the first thing that a structural engineer might notice is you just erased most of my shear reinforcement on the exterior. And they would be absolutely correct. We did do that, sorry. What it meant is that we had to go back inside the building and produce most of the shear resistance per floor in the corridors. And it is possible. Here's an example of floor plan that shows how these units work. But all of the walls that are part of the circulation, all of those become extremely important for developing shear and transferring it to the rest of the structure. This is a typical section. You can see what's characteristic is that every box has a ceiling, every box has a floor. So a couple of things. This building has 30% more wood in it than a standard stick frame. Now, that is both a good thing and a bad thing. The good part of it is that that's all entrained carbon. It's just that we don't really know what happens at the end of life cycle with that carbon. It's like every other stick frame building, but we're working on it. The ultimate goal would be to be able to reuse these boxes in the future, but we'll get there. The other thing that you notice is that it's taller. If you want an 8-foot ceiling or 9-foot ceiling, you've got to add 9 inches to every floor. So can be a zoning challenge. And then the other thing is you just never know who you're going to meet along the way in the factory. So this is, as you may see, one of our speakers that was on a factory tour at the factory in Mare Island. Fascinating stuff. Anthony, you're on.
Thank you, Mark. Well, hello, everybody. It's been great to listen to. My name's Anthony Dente, licensed civil engineer in California, number 80,715. I'm the CEO of Verdant Structural Engineers and Verdant Building Products. We're a proud local East Bay company out in the Gilman District. And we also are licensed across the country. And because some of our specialty in alternative or deep green systems, clients have a hard time finding engineers that are comfortable with these materials. And so we like to help them get the good projects built. And, you know, if I say I did anything tonight, I did it with the wonderful collaboration with all these people. And of course, all our wonderful architecture clients. So thank you to everyone for that collaboration. I'm very grateful for that. We work on everything from small residential to mid-rise mixed-use commercial buildings. We work on a lot of public projects, Native First Nation reservation work, and also tenant improvements. And any East Bay brewery you walk into, we probably anchored their tanks or anchored their bars. But we found ourselves specializing in this category of what we call deep green or low carbon, natural, biogenic building systems. And this includes straw, clay, hemp, and of course, low carbon concrete and mass timbers. But I'll talk more about these some projects. First, monolithic Adobe building in Berkeley on the bottom right, and you know, a light straw clay building with sapling cross bracing in Michigan. You think you've heard everything, and sometimes people bring something new. There's, you know, a straw building, very fun design down in Joshua Tree, and some bamboo work abroad. That was in Nepal, earthquake retrofitting. But we found ourselves the value of having a company of our size kind of strategy. You can't be specializing in alternative materials without being experts in conventional options. And when you're trying to be the best service provider you can be to your architecture clients, your clients abroad, you want to be knowledgeable on anything, all materials that might be applicable to their projects, especially ones they might not know about. And so we have a kind of first of our kind in our not first of our kind, but one of the first in the country of at the scale that we operate in, where we have 15 to 20 people rapidly learning from our conventional projects and applying those lessons to our alternative projects. So we're learning from a hemp project, a technique that was used, and applying that to our next straw clients project. And but then learning things we gained from the quantity of fines contained in Adobe mixes or rammed earth mixes, and applying that to some alternative concrete approaches people are talking about. And this rapid turnaround we're finding to be very valuable and an exciting space to learn. And you know, our primary work is helping people acquire permits with the structural calculations and documentation you need to do that. And for these alternative materials, we found ourselves getting involved in a lot of research. And here's a few fire tests. A lot of these materials I'm talking about perform quite well in fire. But I'm also the vice president of the Cobb Research Institute, Cobb being a monolithic Adobe type construction. And kind of defining that there, it's nice to pause for a moment and identify that these natural building systems, which is a term I don't love, it can be a little alienating, or there are other natural things we build with. And but in general, these they fall into three categories. Many of them are just like wood framing systems. Most of your straw, your hemp, and then light straw clay, which is mostly straw and a little bit of clay, are just insulation systems that we 95 to 99% of the way people build with them, they wrap them around classic wood framing structures. And we have to kind of manipulate how we deal with those wood structures to accommodate some of the needs of these systems. But then there's the ones that are similar to wood or concrete and CMU, and that's your adobe, your compressed earth block, your rammed earth, your cob, and all of these are kind of a different theme on a same subject, mostly clay-based. Did you make it in a block? Did you kind of pour it or form it monolithically? Did you compress it? Did you compress it in a block? And then there's one unique case, which is full bale load-bearing straw, which we use a reinforced plaster system around to resist earthquake forces. And with the permit acquisition work and then research, we realized we could approach the International Code Council and try to affect, and also ASTM at times, try to affect code development in this realm. And I'm happy to say I've been able to play a role in a lot of these that are now codified systems in the International Code Council. I was the lead engineer on a few of them. Most of them are in the appendix of the International Residential Code, the prescriptive code. It's a small first footstep in the door for these materials. There's a long way to go. Only a few of them are mandated for statewide use in California, but all of them are contained in the code for at least voluntary use by the jurisdictions. And I do like to note that so a lot of our work technically, if not officially, falls under the CBC 10411, the alternative materials section of the code. And that scares people off sometimes, but you're really knowing what's truly alternative about your project. It can be easier than it seems, depending on how alternative you are. And so then with working with code development, research, and permit acquisition, we've become attractive to product manufacturers trying to innovate in the space. And this is where I feel like we're really having the most effect on our conventional architectural clients, where some of those building systems that I mentioned there, the natural form of them are at 1 foot to 2 foot thick walls. You're sourcing materials from a straw farmer or a hemp farmer, their byproduct. And these products are changing that narrative. These are you're buying it from official product manufacturer, but they're alternative to the building code in all kinds of ways, some of them in every single way. Our mycelium product manufacturers that we've engaged with. And I've also, it's some of the building science knowledge that we've gained has gone into publications with New Society Publishing. We book on cob or monolithic adobe that we came out with last year to assist anybody trying to get a permit and design with building science in mind. The California Straw Building Association also has an excellent resource and detailed book that we all contributed to as well. And I'm going to end with talking about my second company, which came out of an EPA grant. Again, the Small Business Innovation Research, SBIR, Small Business Innovation Research Grant that the federal government offers. I was scrapping around for a long time with nonprofit work, and only to learn that the government has all kinds of funds for for-profit companies to innovate and create proprietary products. So we optimize straw insulation to perform at equivalent levels of conventional insulations, rock wool, fiberglass, blown cellulose, so that you can have a carbon storing straw wall at a similar thickness as conventional wall systems, which I feel is essential to scaling this material. And so now we're in our phase 1 deployment of early adopter deployment of the Verdant panel. And there are my 2 co-founders there, Rachel Cohen, former Tiffin employee, and also Massey Burke, our materials specialist and director of the California Straw Building Association. But this structural prefabricated panel product that in our phase 1, where we have a surcharge on cost at around $35 a square foot. But our models are showing that if we get the support we need to get to scale, that there's no reason that this will cost more than melting glass or melting rock, which is how we currently make our insulations, most of them. And we're also doing a funding raise on this project too. If you know anyone that's interested in that kind of engagement, please, I'm happy to talk about that offline. But talking about things I bring to my architectural community, this is something we're really excited to bring to the structural engineering community too. We don't get to work with each other very often because you normally only need one company on each job. But here's a way with a material that we've worked with a lot that we feel like we can now share and help others trying to bring carbon storing materials into their projects. And Mark mentioned what's happening with these biogenic materials after the life of the building. We call these carbon storing materials because they absorb carbon into their cells through their lifetime. And if you store that as an insulation in your building, you stop that from going back up in the annual sun cycle carbon. But there's one mark that if in 50 years or 100 years, the carbon being released from our straw buildings that are being torn down, if that's our major problem, obviously we've done something right as a community. And but there is a lot more science and coming out rapidly as we understand and are able to document these kind of dynamic carbon cycles as well. These are rapidly renewable and existing agricultural byproducts too. So these aren't forests that could, still be growing on their own and deepening their relationships and this and that. But anyway, thanks for listening, everyone.
Thank you all. Appreciate it all. Yeah. Before we go into questions that we've talked about, any questions from the audience?
Have the tariffs affected or caused you to change materials, the buildings, and the uncertainties of what's happening?
The question is, how are tariffs and uncertainties of our current political state affecting material and engineering and projects?
So I could say for certain that we've seen a huge surge in interest in volumetric modular because of the potential cost savings. There are challenges to it because you got to get the timber somewhere, and there's limited timber production in the U.S. However, what it does offer is, so many projects are standing on the edge of a razor. And if you can find some advantage that just gives you a little edge, that's going to be enough to trigger them. And so there is an advantage here. There is an edge that's given us, like I said earlier, time is money. So even if your capital outlay is shorter period of time, that could be the thing that makes the difference.
It does benefit trying to raise funds or interest in local supply chains with more localized materials, but I find that it's really hard to predict where these effects are going to take place and when. You think they're going to happen right away. You think all your projects are going to dry up when the administration changes like this, and then all of a sudden they don't. In fact, sometimes you have more work, and so it's hard. It's a hard variable to keep a pulse on. I don't know if you all have that feeling too.
Yeah, definitely that same feeling. We lean a lot on our consultants and on our contractors to really get the pulse of what they're seeing in terms of, where's the cost of labor and materials going? Like, what's the latest thing you've heard? Because I heard this last week, but is that still true this week?
Yeah, I'd echo what Anthony and Winston just said. There's uncertainty and lack of clarity, and we rely on contractors who it's definitely their business to foresee where the trends are going, and how that's manifested for us so far has just been over the last few months more just a rush to lock in before. I mean, this is now changing now, but over the last 3 to 4 months, it was about locking in and rushing to get bid sets out so that before things changed unpredictably, they could lock in. So that has led to a lot more expedited projects this summer as people are wrestling with uncertainty. But like Anthony said, it's hard to predict where it will go from here.
All right. So I think it was interesting looking at your guys' presentations. And Mark, you had brought up this idea of innovation in structural engineering, which I think is perfect given, especially Anthony, what you just proposed. Winston, you showed renovation projects and just how you address those with the wraps on the concrete, or your rise building, the biometric modular. You mentioned, oh wow. I mean, I think all these are really interesting examples. How do these conversations and different innovations change the conversations about engineering and architecture?
Well, I think as Mark, you said in your presentation, I certainly feel it's true for many of our projects where a client may be on the fence about a site. Like, do I buy this building? Do I buy a different building? What's going to be a more feasible building to get what I want, and with the budget I have, the renovation I'm prepared to do, as well as, the kind of projects where you know, like, oh, we have had estimates of like a 14.5, and can we, you know, is there another way to approach this project? Um, that that kind of thinking is really critical very early on in the project. It might be the difference between a project and no project.
One of the things over the time that I've been at Tipping is I've seen that we've had a lot of involvement in developing alternative structural and seismic systems, and that's usually in partnership with universities like UC Berkeley, and we have a lot of affiliation being so close and having had a lot of folks study at Berkeley. And so things like vertical post-tension concrete shear walls, steel strong back mast frames, these are alternative ways of using conventional technology, but in a different arrangement than the prescriptive code systems to get enhanced seismic performance, perhaps without additional cost. And so we've looked for opportunities. And what we talk about internally is that we're never innovating for the sake of innovation. We're trying to find solutions, again, that are going to be valuable to our clients. Nobody pays us to do something cool and fancy that's going to cost them more money. But we can really show them and explain how if you take 12 BRBs and put them in an alternate arrangement and use the same amount of steel, you might be able to get a much better building seismically. And you just have to demonstrate this through analysis and a willingness to try an alternate configuration. And so these kinds of things, again, understanding what the project goals are. For example, we have a project at UC Berkeley right now, the Climate Ingenuity Hub. This is just a few blocks away. And this is a building that's going to be a, what is the term? Incubate, thank you. An incubator space for climate technologies. And so, you know, right away we start with the client. This gets to communication. Is it good enough to just have a code building that you might have to tear down in an earthquake after, you know, something on the Hayward Fault? Is that good enough for this building, or is the potential carbon, embodied carbon of this building something worth investing a little bit more, or at least studying if there are options to improve the seismic resilience? And so on that building, again, we've taken a traditional steel building, used BRBs in an alternate arrangement with a steel strong back spine, and been able to come up with a building that's significantly more resilient for the maximum considered earthquake on the Hayward Fault without a strong cost to add to the project. And so again, providing information and options to our client is, I think, what we're trying to do, never trying to impose a solution, but rather than just going and starting from, we think this is what they want, we try to explore what they might want and present possibilities and information for them to help guide us.
I'm glad you brought that up, Mark, because if you didn't, I was going to mention it, that one of the things we love about working with Tipping is there's a point of view that is much broader than the problem at hand. And so, for example, the vertical post-tensioning, when Leo first introduced us to that concept, it was an eye-opener, because what we are talking about is looking ahead to the embodied carbon of a building and saying, what is that worth? Just as you said, it's worth a lot. In terms of sustainability, you can hardly come up with something that's more valuable in terms of just like the green attitude than save the building. And it's so different than the code perspective, which is get the people out of the building and then you're done. So that's the kind of thinking that really is going to lead us to a better future. And it's remarkable that like the path that Tipping has taken in that direction. It's really great.
Thanks for saying that.
Yep.
Well, it gets to that saying, right, that the greenest building is the building you already have. So, you know, renovation for us, we do a lot of it. We've gotten, I would like to say, pretty good at it. But it's challenging. It's not always glamorous work, but you are extending the life of the existing building stock instead of building a whole new building and all of the environmental impacts that come with that.
Clients come to you, especially because you are known for these alternate materials?
Yeah, I mean, how do these innovations change the conversation? There's two ways came to mind. Is that their normal expectations of what they need to give a structural engineer, or here's a space for your shear walls or spans. They're expecting that might not apply in these unique cases that perhaps both teams are exploring. I'm amazed. I thought I'd going on 20 years ago, came out here to design my first straw bale building. It's got a couple under my belt, and I was like, okay, great, we know how to do this. It'll be easy. We'll crank these out. Still, to this day, like every straw building is different. It's got a slightly different way that we have to deal with the needs of that, and that causes compromise for an idea that people already had in their mind. And you got to get better at recognizing when it's like, you shouldn't put straws. This isn't a straw building. Here's other options, slightly more conventional, still lower carbon, but like the way you have this shaped out. And also the players, when you get third party, like the prefabricated companies involved, I've been, the signing engineer record on a number of alternative material and a alternative assembly approach companies and out of Canada and out of various places, but they don't have California engineers, and they are really driving the show too. And so there's an architect and there's an owner and there's us as the engineer of record, but then all these needs are coming from this other entity, and that becomes this other person at the table that's very relevant. And you got to be talking to them early, asking the right questions too. You don't realize that, oh, you don't put your hold downs, or you don't tie things together in this way that we're used to doing in California. And like, maybe that can still work, maybe it won't, but like, if you didn't realize you needed to ask the question, or wrong, you're gonna get down that path.
Yeah, we've had that experience with sourcing materials from China quite a bit, where they're very interested in the market. They are very innovative. In fact, one of the things that we've seen is they're leading the charge on mass customization, which is a strange concept. But there are factories in China that what they do is they'll go measure an existing space, and they will use that data, feed it into a bunch of machines that will then crank out an interior based on your selections. You go to the showroom, this is like IKEA on steroids, and you say, yes, I want this to look like that last scene in 2001: A Space Odyssey. And they say, got it. Here's the dimensions. They send out a laser to measure it, and then boom. Problem is that if you ask them for their ICC certification for the plumbing connections, they cannot produce it. And so it's just you're saying, Anthony, there's certain questions you have to ask, like right up front. For instance, how are you making the plumbing connection in your bathroom pod? Oh, well, we can't do that in the US. We require rigid 2-inch connection. So even though it's innovative, even though it could really make a difference, can't be done.
I mean, there's special challenges of being in California in seismic areas, right? Imagine like some of the challenges that you're facing doing projects here, straw bale world, aren't as big of a deal other places, or is there just maybe there's also positives about California and just being more progressive and understanding things and adopting these ideas. I mean, and also modular, like all the things that we're talking about for the people who you're doing things outside of California.
Well, it's a very intricate calculus that goes into it, because modular does not make sense, for instance, in New Mexico, because the labor pool is plentiful and cheap. And so you can still do things. And also the seismic zone, I don't remember what the zone is. It's something really low. But so you have 800-year-old adobe structures all over the place. Stacked rock still works there. Whereas here, of course, the land likes to sway and dance. And so you do have to account for that. But the economy is also a huge part of the equation. So just to give you a sense of it, modular makes perfectly good sense on a prevailing wage project, because the work that's done off-site is not subject to prevailing wage. Now, certain audiences, I don't say that out loud because I don't like getting booed off stage. But the truth is, there's a shortage in the labor pool. And so this is an opportunity for the building to get done and for everyone to benefit. There's still a site team that's done at prevailing wage, but 30% of the budget of the building can now be done for the wage in the factory. For the people who work in the factory, it's a stable job in safe conditions, protected from the weather that they can drive to 5 days a week. And so there's benefits for everyone, but that's just like a little thread that I'm teasing out that shows the kind of intricacy of it when you're trying to make a decision, besides the structural.
Social aspect does come into play with alternative materials. A lot of people look at, like, there's a renaissance of clay construction that happened in the Western United States, and that's not because seismic was asking for this. It's because more alternative personalities that were exploring these concepts happened to locate out here, as far as I understand the history of it. And there are a lot of pockets, though, with these, adobe materials and clay-based concretes. There are a lot of pockets of size design category C across the country. I just did a size design. I do size design category C in New Mexico, Indiana, Tennessee, near the Blue Ridge. And when you're dealing with these higher mass building systems, that starts to matter in C. And so you're being well versed in it in some respects. But then also the straw community found this reinforced plaster wall system that had this ductile inner core, and David Marr and with Tipping Marr was involved with that early development too, along with Kevin Donahue, our former senior principal. And there was fascination that kind of, I think, fueled the development of it through that aspect too.
I was very interested in that as far as different scales. And Mark, you had mentioned this, that you're kind of do all scales, right? So you're showing really big buildings, and then you're doing single family housing. Winston, you're kind of, yeah, you have larger projects too. Like, so what conversation, what changes with these different scale projects?
So one of our high-rise renovations was essentially we rebuilt a new high-rise inside of an existing high-rise. So we like to say our scale is everything from the scale of a shipping container. We have done a couple shipping container projects up to a new high-rise. Yeah, I mean, certainly there's differences in approach to those different scales. Like, I think, like any project, you're thinking about, like, where can you have an impact? And teasing out, like, what's most important about this project, where with like repetition and like multiple floors, like, how can I get an impact, but now I'm dealing with 20 floors? So maybe it's a strategic move in the elevator lobby, and then you focus on the common areas. So it's the same question of, like, where do you prioritize? It's just affected by the scale.
Yeah, I think one of the things I've appreciated listening to the panel is just talking about how, every project is unique and every project has unique challenges. And to really be an effective designer, you have to be able to be sensitive and have solutions. And just repeating the same thing over and over again is can be kind of stifling to your ability to help your clients. And so the scale, working on different scales of projects, is a way that we train our engineers to be problem solvers. They get repetition of seeing a client start, have an idea, and wanting to, figure out how to get them through the process and then complete it on small artwork or small tenant improvements. That cycle can be anywhere from 2 weeks to a couple months. But that's a very formative experience. If I can get engineers to take it from the beginning to the end 5 or 6 times, it's like repetitions. It's like exercise. You're getting repetitions to see the whole cycle. If you stick a new engineer or a new architect on a high rise for 5 years, they could be great at door schedules, or they could be great at designing columns, but they might not get the breadth of experience. They might not get an ability to be in as many client meetings face to face with a client and understanding the subtlety of what they're asking. They might not get out on site to see construction in the same way. They might not get panicked calls from the field until year 4. So there's just a lot of benefit to being nimble, as the word came up, and being having a big tool belt of a lot of different tools that you get through that repetition, which is one of the reasons we really like working at various scales. And again, our clients have a lot of different projects too. So I don't want to tell a client, don't call me for this when they're in need of help. If they want help on something small, we can help them. And then when there's something else different, we can help them.
For us, an experienced architect, there's nothing more fun than watching the junior architect field that call from the field. So it's like a little bit of entertainment in your day. We all had to do it. We all had to feel the flood of anxiety and then learn how to manage it. But I'm sorry, I still get a kick out of it. I must say something about me as a person. It is good for you. It's good medicine. And that's how you become an experienced expert, is you deal with it. For us, I think on the scale question, we do have a series of high-rise projects in Hawaii right now. The tallest one, I think, is, it's a 2,500 unit project, so it's a big project. But how it alters the process is that we spend more time dealing with the general and then move down into the specific, rather than on the smaller projects, we kind of go straight to the specific. I mean, you entertain different solutions, but the effort is focused. The problem is smaller. When you're talking about a high-rise building that has a parking garage attached to it and some cantilevers sticking out, this is where I personally delight in working with the engineering team, because you do have to go through these iterations, and they start with big ideas. Like, how can we deal with this as a big idea? And then you get into the next stage. How can this big idea be executed in a way that is efficient and sensible? And then how do we detail it? And it's fascinating.
Sometimes it's so nice to work on different scales of projects, because small scale solutions can apply to big scale projects and vice versa. And I think about this a lot with retaining problems, that we retain incredible amounts of earth on our highway systems with like relatively low carbon, like they're not monolithic concrete shear walls, but yet that's like what all residential construction uses, these pretty high carbon solutions. And so how much can we scale down these bigger scale systems like mechanically stabilized earth or passive wall systems that are just I see used so rarely, and I'm talking larger residential renovation or manipulations, but site manipulations.
Yeah, I want to pick up on that. That's, one of the great training areas for young engineers, because, it can be hard as an architect. Like, one of the things that's not great is when your engineer comes back and says, the footing needs to be 3 feet wide and 6 feet thick. You're like, are you sure?
No.
And, these small projects, when you have, a young engineer working on it, sometimes it's their first time through and they don't have the sense of what it might look like. And their whole goal is to kind of get the answer right and make sure it's not wrong. And they give you a 10-foot pier for a sign or something like that. And so getting, again, the repetition of what is the answer, you're going to actually communicate that answer. Let's go see why you got to that answer. And let's figure out why, like, just following a recipe can lead you astray. And what are some things you need to think about from first principles to arrive at the right solution? That whole exercise of like checking your work and understanding context and understanding, that the world's built this 100 million times. And so this isn't the first time. So how do you get down to something as lean as possible? That's skills that you can take into larger projects. But it really starts with younger engineers kind of doing their first footing. I mean, that's like, talk about enjoying watching this. I've enjoyed watching I know that the first time I would give a young engineer a retaining wall or a pole footing, they're going to come back with a 6 foot wide footing, 4 foot retaining wall, and it's got a 5 foot wide footing. And you're like, what buttons did you press at that program? And go look at that. Nobody engineered that retaining wall over there. So again, there's so much value for really understanding the practical nature of our business that comes from the repetition in the small projects.
Well, the other thing is that I have heard structural engineering compared to like differing forms of religion in terms of the schools of thought. And so there's that dimension as well, where it depends on what you have faith in a way. And I don't mean that as any way to demean religion, but it does show that the conceptual basis is fundamental. And that, again, while we enjoy working with tipping, is that the conceptual basis is more expansive. And we've worked with there are conservative structural engineers out there that will give you the 5-foot thick shear walls at the base of a tower, and the 12-inch thick PT slabs. All of that is just part of what fundamentally you believe in. And so it's fascinating that even within the context of your practice, it starts off with something that you can really rest on. And then as you develop experience over time, you know where the real meat of it is.
There's so many things I want to kind of respond to. I mean, I think, like one, I think we should all kind of compare notes about, like how do we like train staff and bring people up, in the profession, whether it's architecture or structural engineering. And certainly, I have had many an experience where there's a senior engineer and a junior engineer, and I ask if the senior engineer can come to the site visit because I know they're going to have that experience, that depth of experience to be able to have a sense of what the solution could be without the factor of safety being like 20. Like, okay, can we get to like 2 or something? But I also think that as we speak about experience, there's also like different kinds of experience. I look at my staff, and now I'm getting to the point in my career where I'm not that old, but I'm kind of old. So there's stuff that my staff can do that I can't do anymore, which is really humbling. And they bring this experience and, agility, adaptability, and fluency with all these different programs. That's really great. I think because so much of our work, particularly on the services side, requires that we kind of tap into hearing people's stories and lived experiences, that I find that conversations with my staff, I'm learning as much from them and how they tap into their own experience in the communities they're a part of. So there's many kinds of experience. I think I wanted to kind of interject that. It's not just like this linear, like, oh, you get to a point where you're the senior architect or the senior engineer and you know everything. I feel very much I'm kind of at this point where, because things are changing enough in the world and changing rapidly, I feel like the learning is, bi-directional.
Yeah, I love that. That's amazing. Yeah, because it's always been like an architect, right? The major architect, and then everything kind of goes down from there. So yeah, appreciate you saying that. That's an interesting perspective. Oh yeah.
Want to take exceptions to something Mark said,
Sure.
the religious aspect.
Structure.
I think it's
Yeah.
gonna go longer. I'm gonna give you a mic.
Thank you.
I wanted to take exception with something that Mark said about the religious aspect of structural engineering. Religion is based on faith. Faith is a belief system that doesn't rely on evidence. As a matter of fact,
Point taken.
and a structural engineer's experience feeds the judgment of the engineer. And if an engineer went through a 50-year career like I have, and sees that things can get out of hand and knows how to prevent that at the start, some architect might think that I'm over-engineering, but in fact, what I'm doing is applying my judgment and understanding how things fail. In fact, as far as I'm concerned, everything is over-engineered until the moment it falls down.
Yep. Yep. No, your point is very well taken. I think that my experience is based on having different structural engineers approach the same problem. and come up with wildly different answers, just kind of based on the fundamental approach. And so, again, I'm going to remember not to use that analogy ever again.
But just to be clear, that fundamental approach that each engineer arrives at or applies comes from that engineer's own experience.
Of course,
And if the engineer has had 50 years of no problems, he might have been lucky.
very good point.
One of the things that I always remember, there's a consultant that we worked with for a long time. He knew Steve Tipping and he worked with Leo very often. His name's Chuck Thiel, and he developed the PML method for rating buildings. And he once said, I don't always judge the engineer's design as if, and I forget the exact words, as if this is, fully reflective of their work. There were all sorts of constraints that were put upon them at the time by the client. Now, of course, every engineer has to have the integrity to tell their client what they need to do and what's going to be legal and what's the minimum requirement. But after you've done that, like we've been talking about here, different clients want different things, and different clients, will have you explore different things, whereas others, really just want you to be in the corner and give them the answer. And some people want a conservative design. Some people want you to be as aggressive as possible within the boundaries of safety. And so again, we have an ethos and an integrity that we're always going to have to feel good about our design. But I've found it to be more and more true that when I'm actually listening to each client, my approach, there's subtleties to it, but my approach to the project is actually going to be a little bit different and influenced to some degree. Not, and I also take the point that, there's the minimum level of safety and physics that all engineers have to follow. But I've continued to reflect on how I operate differently for different clients because I'm trying to give them what they ask for. And there are times where I say, I can't get that to you, but.
If I could add
Yeah.
something that Mark just said, the fact is that we work in areas of constraints. We're always constrained. Thanks. Like an engineer wants a shear wall and an architect wants a window. So there's always a negotiation. There's an effort to, it's a term called satisficing, where you try to get the solution that dissatisfies the most people you can, as little as possible. But you're not going to satisfy everybody because it's a satisficing process. Somebody's ox is going to get gored.
What I appreciate a lot is when we're brought in at the beginning, whether it's a retrofit or whether we're a trusted partner on a new building, and you can start with a collaborative design process where you're listening and then you're kind of able to claim structural space or say, if we're really trying to pursue what we're all talking about, this is kind of the structural approach. And so, there are many, many examples, and we do it all the time where we're brought in at design development and the constraints are pretty well set. The challenge of asking an architect or the design team to move things at that point is a real challenge. And I understand why it is. So again, we always appreciate being brought in earlier. You have more flexibility to work together as a team and optimize the whole system.
And at the end, when the price of the project is much higher than the first. When the price comes in at the bidding stage, and it's much higher than that first guess that the contractor provided, if with just design development with no structural engineering input, the architect and the engineer get blamed for that because the contractor says, well, this is much more expensive than it has to be. But in the meantime, the engineer has to work around all the non-structural problems, all the structural problems that the architecture imposed without having early input of the structural engineer.
Yeah, that's why we don't wait until the end of DD to work with our consultants. It's always at the latest, the end of ST when things are still fungible. Because your point is very well taken that if we lock in the form of the building before you've had a chance to tell us how it really is going to work, we're just asking for trouble. I've been doing this now I know it probably doesn't look like it, but I've been doing this for 45 years. And in that time, what I've learned is, first of all, don't put openings near the corner of a shear wall. So of a shear core. Yeah, no, I've had it, I've had it drilled in, but it is true that the preferred mode is to collaborate from the beginning as much as possible. We do a lot of entitlement work where there's no way that that client is going to hire the engineering team. They're trying to get to, you know, some form of economic return before they start spending money, but immediately thereafter, there has got to be an engineering team, or else it's just, I mean, we're not qualified to even speak to that stuff. And frankly, we want the assurance that we're doing it right, that we are not leading our client down a road that has bad ending. So completely on board with that. And like I said, I think the analogy fails on several counts, but just that everyone has different approach based on their experience.
Mhm. I would echo the sentiment about bringing your structural engineer on as early as possible. And go, even a little bit earlier in the process. For some of our renovation projects, the client doesn't even own the site yet. And, we may be part of a real estate search with them for a couple of years. That was the case for Girls Inc. For a meditation center that we're currently working on, we studied 7 different sites before we settled on a building that they wanted to go ahead and purchase. And each one required a test fit conceptual design phase where we included the structural engineer to provide an assessment of that existing building that we were starting with. Like, is this a good site for our client to pick? Are we, biting off more than they can chew with this particular site? So we have had them involved in the scoping and feasibility phase as well.
That's lovely to hear. The idea of bringing architects and engineers together as early as possible is fabulous. I'm an architect and I'm a licensed engineer. So
Oh,
go that.
2 for 1.
Yeah. On the subject of sort of engineering and architectural collaboration and how that works, I was wondering if anybody has any ideas, either sort of things that really work well or the stories of what really didn't work well. My original thought was, for modular, there are all these third parties who we're having to deal with. It's not just engineers and architects. There's contractors, there's owners, there's funders. There are, and particularly for modular, there's this whole other piece of how is the modular system being engineered for alternate building materials. I'm assuming there are material suppliers, there are people who've, specialty contractors who've worked with this before, not to mention just sort of generally the contractor, the owner, like anything about the process of how engineers and architects can work together that has worked really well in terms of interfacing with those other parties external to the engineer architect relationship, or things that work well, or things that have just, horror stories of what hasn't worked well.
Well, what I would say is that what in volumetric modular, it's important to only have so many rookies on the team because there's a lot to understand. There's a lot of kind of assumed knowledge. And so if our client, it's their first time doing a modular building, we make sure that every other member of the team has done it before. If you have 2, it's just the recipe. That's our recipe for disaster, because if you have 2 inexperienced players that have decision-making capability, then it's hard to bring them into alignment. And that goes from the structural engineer. We work with structural engineers, mechanical engineers, contractors, especially contractors. In contrast, we did a hotel in downtown Oakland where the general contractor decided to take on the task of setting the mods, and it was their first time. And so they were setting like 1 mod per day. And an experienced setter will do a dozen. And you can imagine what that does to the schedule, to expectations, and they're having to do things and then undo them. So that the main thing is like preloading the experience. You kind of have to have it. What's fortunate is that more and more parties are getting that experience, and so you still have a pretty wide range to work with. But just to address your question, that's kind of it.
One thing that I've seen work well, but also not well, is the role of the architect as the project manager, which I'm very grateful for. I do not want to be the project manager, but it's the value in them being the point person for all these collaborators. But then sometimes you realize, but sometimes you realize too late that you're getting the information translated through someone who knows it less than both you and the original person, and kind of trying to avoid that. I mean, nobody wants meetings. I try to speak up when I'm like, I don't need to be here when you're talking about what plants are going into the landscaping, but I do need to know about that one piece of landscaping that's affecting structural. So I recognize it's difficult to have all the players at one meeting, because you're going to go off into subjects that not like these people are billing for this meeting and they don't need to hear about this. But doing your best you can to. And another thing, the owners come into play with that. I was thinking of Mark was talking about the conservative versus unconservative design requests, from different clients, like some architects, especially like the deeper green sustainable architects, like we most efficient material use, and they're like, well, roof deflection requirements are kind of liberal in the code, we can push this. And then the contractors letting the owner know later that like it's really bouncy up here, they did not design, you didn't get a good building. And I find out later that the owner is a pretty conservative person and actually wanted us to over design, but yet I'm kind of working through the architect in any way that owner can be a player that you maybe want to be hearing more from directly to. It's complicated.
And I think another part of that is that you as an engineer could have a contract with the owner and not be intermediated by the architect. I used to have worked under architects as a sub-consultant, and my information could never get to the owner. There's always censoring.
There was a piece about information flow, like, because I've also been in a situation where I am blessed to have the architect shielding me 95% of the chaos and filtering it out. Oh, we went through 15 design iterations, but you didn't have to listen to them. Here's where we landed, which is great. But then there's also where that level of mediation is detrimental, right? You're not communicating with the person you want to communicate with. You're not understanding what the owner is really wanting. So like there's a piece of the engineer architect collaborative relationship about understanding where and when and how to communicate. And it goes back to trust and communication.
Yeah, it is possible to both over communicate or under communicate. And I've had projects where just like everyone works a little bit differently, and you see like a particular team of consultants come together in that particular mix for a specific project, and you see kind of their appetite for how much they want to be updated, what they care about, and all of that. And certainly within the same team you can have people like, that's way too many meetings for me. I don't, tell me when something comes up for me. And we have our consultants who I'm like, I don't know if you need to be here for this one. Like we are just talking about plans this time. And it's really kind of a process to find, that right level. And that's experience working together and building trust over time. So, the learnings from previous projects kind of translating, as well as, what's right for that specific project and that specific team.
Well, we have reached the end of the night. I do have more questions, but I will not ask them. But this is a great conversation. I really appreciate all you participating. Thank you for all the great questions and insight from the audience. We will be meeting back next month for MEP and architects talking. So I think these conversations have been wonderful, informative. I think we need to continue figuring out how to have these conversations about design outside of a project, how how we communicate, all these things that we've been talking about tonight, I think is very important for all our consultants. So I'm glad that we've started the conversation. Hopefully we can figure out how to continue it either here at the AA's Day or other places.
More slide.
All right, help us improve. Please take the survey and tell us what you thought of the nights and give us some good criticism as appropriate. Thank you all.
Thanks for coming.